Hi, my name's Stuart Macdonald. I work for a data centre and I'm the University Data Library. We have been making major investments in research, data management, infrastructure, storage, services. And it occurred to me that the poor relation in this activity is data reuse. So with that in mind, I applied for an IS Innovation grant with the view to bring in PhD researchers from across the schools and colleges here at Edinburgh to look at innovative ways of using and reusing data, with each constituent applying their own disciplinary or subdisciplinary process, method, workflows, etc., etc.
Normally, when people think about data, they think about one big entity. If you think about data more as a cityscape, a landscape, each with its own little towers and peaks and troughs, and you consider each of these peaks and troughs as fields unto themselves, that is more representative of what data really is. This exhibit was specially focusing on how data can be presented to the public in an interesting way. What I had wanted to do originally was to interconnect this thing with things like oscilloscopes and function generators, and give like key points where people could come in and interact with the exhibit and plug in their function generator, play the guitar, and see the frequency response and the waveform shape, and learn a little bit more about the qualities of sound that are just beyond what you can hear.
As you can see behind me is a world temperature data quilt. We took a global temperature data set compiled by the University of East Anglia Climate Research Office and the Met Office, and they record temperature anomalies, so how the global average temperature in each month compares to a baseline value they've defined. And what you can see here is each row represents a year and each square a month in that year. And we've defined their color scheme: bluish, purplish colors for colder anomalies, negative anomalies compared to the baseline, and the yellow, orange ones for positive anomalies, so when it was hotter than the baseline temperature. And in general, you can see that there's an increasing trend. So 2016 is the last row, and you can see everything is yellow, whereas in the 1800s it was much colder.
Well, we're trying to make a metal sintering furnace using a commercially available microwave. So what we did was to do some modifications into a normal microwave where we have this PID control. We have the temperature and a limit of the temperature, and inside we modified it as well. We drilled 3 holes in here, one for the thermometer ventilation and the other one for a small camera so we can see inside. Inside of the microwave cavity we have fire bricks, which are bricks made of aluminum oxide, and some ceramic wool, just to make that the heat goes where we want it. We have a graphite crucible inside, and we've been able to melt some bismuth, some glass, and also aluminum.
So this installation, called Soundbox, is drawing from the idea of the music box as a mechanical device that produces music, melody. So through a series of sensors that are attached to the interactive floor, the movements of the users are fed into a processor that applies modifications to the drawn sounds, therefore composing the music and changing the music as users move around the space. And at the same time, there is a drawing of the space produced by the transference of the vibrations of the sounds into a flat membrane.
The main project that I work on is to do with navigation. Really, it's to do with how people move around, particularly like complex cities. And the thing that we're working on is how you kind of model the underlying kind of spatial relationships, so that you can then show people slightly different ways of kind of visualizing the city to help with navigation, particularly where you're moving between like different types of network.
I mean, I'm the kind of person that I get really exciting about finding treasures in what people seem to consider trash, right? So I really like the idea that, okay, you have this pile of data that you don't have anything, you don't know what to do with, and all of a sudden you find something to do. Having to be clever about how do you handle all these amounts of data, trying to find the patterns in the data and actually trying to create a use that nobody expected would be there. So this unexpectedness of the hidden mysteries of the data is what really excites me. And precisely, for example, in input-output information, like the one we actively generating in this installation, in the mannequin.
So the most challenging aspect for me was learning getting some hands-on experience on all the electronics, doing soldering, troubleshooting, because we had some LEDs strips that did not work, so it took a while to arrange and figure out what is going wrong. And although it was quite challenging, it was very satisfying in the end as well, learning all these new things.
I think that we had an opening event of which there was maybe 120, 140 people attended. The perception I got was one of intrigue and one of excitement and one of curiosity. You could see light bulbs switching on in people's heads as they started to comprehend and understand the thinking behind each of the installations.
The lesson that learned here from the DataX experience, I'd say, has been quite enriching and quite engaging in the fact that we were able to meet so many different disciplines, people from different disciplines, students that were engaged and involved from geosciences to engineering, from engineering to video and art. And so it was quite a very, I'd say, surprising, rewarding experience, and that the fact that we were able to get so many different sorts of exhibition types that we would not have been able to do otherwise if it was not this cross-interdisciplinary experience.
So in terms of what was the most rewarding aspect of delivering the exhibition, it became apparent that there was very soon an appetite for this type of activity, bringing in together researchers from the arts, from the sciences, engineers, from the medical sciences, for this kind of cross-collaborative type of work. Is that there's been networks and partnerships and collaborations that will continue beyond of the DataX. Data is everywhere. We use, we generate, we manage data on a daily basis, at work, at home, and at play. There are conventional data, such as audio files and databases, spreadsheet, images, but there's also more complex digital objects, 3D chemical structures, data generated from sensors, engines, GPS, satellites. We have the Internet of Things. Data can be transactional or administrative, observational, experimental, derived, simulated. In the modern world, we're immersed in data. It's the new oil. What was of particular interest and what we try to encapsulate and highlight in DataX was that there's a preponderance of discipline-agnostic data sources across the web being generated from, as I say, sensors and such like. There's open tools, there's platforms, there's analytical frameworks. The key, however, to unlocking the vast untapped riches and to maximise the potential of this rich array of data are ideas. And if DataX was about anything, it was about the cross-fertilisation of those ideas and thinking through innovation and data reuse. This was but the start of an exploration, but it was a very encouraging and thought-provoking one.